So now we're going to start solving some linear equations. And remember, linear means that the variable is not raised to any power higher than the first power. So here's my strategy for solving linear equations. These are the steps that I like to go through to take any linear equation and break it down to just x equals some number. Step 1, if there are any parentheses, remove them using the distributive property. Then step 2, if either side has any like terms, so if there's more than one x term on the same side or more than one constant term on the same side, combine them. Then, by adding or subtracting the same term on both sides of the equation, get it so that you get just an x term on one side and just a constant term, a number by itself, on the other side. And finally, to get from an x term, something times x, to just plain x by itself, divide both sides of the equation by the coefficient in front of the x. Or if it's a fraction, it might be easier to think in terms of multiplying by its reciprocal. So, with that strategy in mind, let's work through some examples. Let's solve some equations. So here we have 2 times, in parentheses, 3x minus 1 equals 2 minus, in parentheses, 4x minus 6. So first thing in my strategy is to remove the parentheses. So here I would multiply through by the 2. 2 times 3x is 6x, and 2 times the minus 1 gives you a minus 2. Over here, if I remove these parentheses, I have to distribute this minus sign that was in front of them. I get minus 4x, and I get minus, which is plus 6. Okay, then step 2, if we have any like terms that are on the same side of the equation, combine them. So what I see is over on the right side, I have a 2 and a 6 that I can go ahead and add together and get 8. So now each side is as simple as it gets by itself. 6x minus 2 can't simplify that. 8 minus 4x can't simplify or combine anything there. So now we want to get it so that one side is just for x terms, no constants, and the other side is just for constant terms, no x's. And we could do it either way. We could decide to put the x's over here and the constants over here, or the other way around. I decided I want to get rid of the minus 2 so that I have just an x term, and I can get rid of the minus 2 by adding plus 2 to both sides. And if this is going to be the side for x terms, then I don't want any x terms over here. I got to get rid of the minus 4x, so I will add plus 4x to both sides. So once I've done that, over on this side I have 6x plus 4x, that's 10x. The minus 2 plus 2 just added up to 0. So all I have left on the left is 10x. And all I have left on the right is 10. 8 plus 2 is 10. The minus 4x plus 4x canceled out. So now I'm down to where I have an x term, something times x, equal to a number. Now to go from 10x to just x, I divide both sides by 10. 10x divided by 10 is just x, and 10 divided by 10 is just 1. So there's my solution, x equals 1. Now, if you have done everything correctly, if you haven't made any mistakes, that should work. That's guaranteed to work if you did everything perfectly. But if you're not sure, if you want to check, we can go back up to the equation we started with, put 1 in place of x, and make sure the two sides of the equation do evaluate to the same number. Over on the left, if x is 1, inside the parentheses, 3 times 1 is 3, minus 1 is 2, and then the 2 times the 2 would be 4. Meanwhile, on the other side, inside these parentheses, 4 times 1 would be 4, That 4 minus 6 would be negative 2, and then 2 minus negative 2, same as 2 plus positive 2, that would be 4. And since both sides evaluate to 4, they are equal to one another. The equation is true when x is 1. And by the way, since this equation has a solution, it's true on the condition that x has to stand for the number 1. This would be an example of a conditional equation. Another example for us to solve. 5 times, in parentheses, 1 minus 3y minus 6 equals 3 minus 11y. First thing to do, remove the parentheses. If I multiply this out, 5 minus 15y minus 6 equals 3 minus 11y. Okay, now do you see anything that we can combine? Any like terms that are already on the same side that we can just go ahead and combine? Well, over on the left side, there's 3 terms in all, and 2 of those terms are constant terms, the 5 and the minus 6. So we can combine those into minus 1. All the other terms stay the same, and we have minus 1 minus 15y equals 3 minus 11y. Now here's where we get it so that one side is just for y terms, and the other side is just for constant terms. So I added plus 11y to both sides. Negative 15y plus 11y gave me negative 4y. And I added plus 1 to both sides. So then over here, 3 plus 1 gave me 4. And now to go from negative 4y to just y, divide both sides by negative 4. Negative 4y divided by negative 4 gives me y. And then 4 divided by negative 4 gives me negative 1. So there's my solution, y equals negative 1. I'm not going to check it, but you can if you want. You should get the same value on both sides if you put in negative 1 in place of y. How about this one? 5 minus 2 times a minus 3 equals a. So let's see. Can we go ahead and subtract here? 5 minus 2 is 3. Can't do that because the 2 here is being multiplied by the expression in the parentheses, a minus 3. The 5 isn't. And we are not allowed to subtract before we take care of this multiplication. Multiplication comes before subtraction in the order of operations. So this is not what we want to do. This is not legal. What we do want to do is use the distributive property to multiply this out and get those parentheses out of the way. So when we do that, we get 5 minus 2a, and then minus 2 times minus 3 is plus 6. Careful, remember when you have a minus times a minus, it's a plus. Now, do you see any like terms that are on the same side of the equation that we can go ahead and combine? Aha, there's a 5 and a 6. 3 terms altogether, 2 of them are like one another because they're just constant terms, so we can combine those into 11 minus 2a equals a. And now add 2a to both sides. We get 11 equals 3a. This time the a term, the variable term, is on the right side, but that's okay, nothing wrong with that. And to go from 3a to just a, divide both sides by 3. So 3a divided by 3 is just a. And then over here, 11 divided by 3 is 11 thirds. It's 11 over 3. You could write that in decimal form. It would turn out to be 3.66666 repeating forever. But might as well just leave it as a fraction. So when you're solving an equation, the solution might turn out to be a whole number, or it might not. It might be a fraction. Okay, let's try this. 3 times x plus 4 minus x equals 2x plus 7. First thing to do, let's remove the parentheses. When we multiply this out, we get 3x plus 12 minus x equals 2x plus 7. Now combine like terms. Do you see any terms on the same side of the equation already that we can go ahead and combine? Well, on the left side, there are 3 terms in all, and 2 of those are x terms. 3x minus x, and together those make 2x. So 2x plus 12 equals 2x plus 7. I'm starting to get a little worried about this, but let's plow right ahead and subtract 2x from both sides. And then, on both sides, the x terms go away. 2x minus 2x is 0. And what's left is 12 equals 7. And we could keep on. We could subtract 12 from both sides or subtract 7 from both sides. We might end up with 5 equals 0. But at this point, with all the x's gone, we have an equation here that is just plain not true. 12 can never equal 7 no matter what number we put in for x. So what we have here is a contradiction. It's the kind of equation that has no solutions. Since this is never true, but it's equivalent to what we started with, that means that what we started with can never be true. There's nothing you can put in for x and have these two sides come out equal to one another. So that's how you recognize a contradiction. If you're going about your business, trying to solve it, doing what you're supposed to do, and somehow all the variables drop out, and you're left with just numbers, but those two numbers are not equal to one another, so you have an equation that's just plain not true, that's a contradiction. Now, what about this? This looks almost the same as the last example, but with a little difference. Let's go ahead and solve this the same way we did the last one. Remove the parentheses by distributing 3 times x plus 3 times 4, so 3x plus 12 minus x. Combine like terms, we get 2x plus 12 equals 2x plus 12. That looks like it's the same thing on both sides. And if we went ahead and subtracted 2x on both sides, then it would say 12 equals 12. So again, the x's have disappeared. We get an equation that just involves numbers, but this time this equation is true. It's true that 12 equals 12. So no matter what x is, we've got ourselves a true equation here. This is always going to be true. But it's equivalent to what we started with, so what we started with is always going to be true. What we have here is an identity, an equation that is always true. It's true for any real number that you put in place of x. Okay, one thing we haven't talked about yet that you do need to know how to deal with is, what if your equation has fractions? Oh no! Don't get scared, don't get intimidated. We can deal with that. I'm going to end this video here and come back in the next one, and we'll see how to take an equation that does have fractions and turn it into a nice, innocent little equation that doesn't have any fractions.